Welcome to the online lectures for software engineering. In today's class, we'll be discussing the CMMI model, the capability maturity model integration. This particular model, it was developed by the Software Engineering Institution. The SEI designed this particular model. Now, this model was developed so that you can improve the product quality, that you can improve So this particular model was developed so that you can improve the product quality. That is whatever software that you're developing, how you're going to improve the quality. So this model focuses on improving the product quality, and it also helps to develop efficiency for not only hard software but also hardware. So it is going to provide you with the entire best quality software, and it is also going to provide you efficiency for hardware as well as software. And the next thing is that this for when this CMMI model was developed, a few companies were involved when the levels of CMMI were defined. The companies that were involved were Ericsson and Motorola. These were the companies that were involved for defining the CMMI levels. Now, the CMMI model can be represented in two different phases, that is a continuous model and a staged model. Now, in here, continuous model, it is going to focus on process areas. Now, in here, process areas are going to be different types of areas. Like a process area, it is a related practice in one area. Now, in here, if we give an example of a related practice in process area, it can be requirement gathering or project planning or the configuration management. These are your process areas. Whereas staged model, this is based upon improving the maturity of the levels. That is, in here, it is based upon an organization, how they are going to improve the quality of the particular process. Now, in here, within this continuous model and staged model, you've got like similar content. You've got nearly similar content for the continuous and the staged model. Now, let me show you a graphical representation. Now, in this, the right side of the diagram, this is your continuous model. In this continuous model is a two-dimensional model. Now, two-dimensional model in here is you've got your x-axis and y-axis. That is your two-dimensional because your 2D representation. In here, on the x-axis, you're going to have processes and you're going to have capabilities on the y-axis. Now, in here, you can focus. You can see that the capabilities in here are numbered as 0, 1, 2, 3, 4, 5. That is, they are going to be 6 levels in continuous representation. Each and every process area it can achieve any level of capability. Whereas at the left side, you can see that you've got the staged representation. In staged representation, you've got an organization. This entire organization are going to achieve different stages of maturity level. There are 5 stages for maturity that grows. So in here, you can see that in here, this is going to start from 1 to 5, whereas in continuous, you're going to have from 0 to 5. So you're going to have 6 levels in continuous and you're going to have 5 levels in staged representation. Now, a few examples of process areas. I've given 2 examples. The others are REQM is requirement management, PMC project monitoring and control, PP project planning, CM configuration management, MA measurement analysis, and PPQA is process and product quality assurance. Now, in here, process area means you're going to focus on one particular thing. Now, this one particular thing, it can achieve any level of capability levels. Now going on to the capability levels. Now in here the first model is continuous model. Now in the continuous model, the different levels that we have seen, these different levels will be called as your capability levels. These levels are called as your capability levels. Now in this capability levels, you can see that the next one is, it is going to help the organization select specific improvement that best meets its business objectives and minimize the risk. That is, in here, this organization is going to identify which particular business practices you need to apply so that you can minimize the risk in here. The next point is, as we have seen that this particular process, it is two-dimensional of X and Y axis. You've got process and capabilities, different 6 levels on the Y axis. Now, going on to the 6 different levels of the continuous model. The 6 different levels, level 0 is going to be called as incomplete, level 1 is performed, level 2 is managed, level 3 is defined, 4th will be quantitatively managed, and level 5 is optimized. Now we'll go one by one about each and every level. Now in here, this incomplete level, this level is called as your level 0. Now within this level 0, in here we are going to focus on process areas. If you remember, process areas. Now if we take an example of process area, it can be any requirement management. Process area is requirement management. Now in here, if suppose this process area in here, this process area, that is first process area, it is either not performed or it does not achieve all goals and objectives that are defined by CMMI. That is, this is not complete, incomplete. You do not have any goals and objectives that are not defined. You just know that a software need to be developed. Now coming on to the next level, that is called as your perform. Now this perform level, this is called as your level 1 criteria. In this level 1, in here it means that the goals are satisfied. That is, in here first they were not known, but now in here you know what goals you need to achieve. Then work tasks required to produce work products are conducted. That is, you have started working on this particular software. Now if you remember, what are work products? I'll give you a quick review again. It can be any document, it can be any file or report. That is, you're going to perform a few tasks so that you can make these work products. That is being started. Now coming on to the next level, the next level is manage. Now this manage level is going to be level 2. Now from level 2 in here, this level 2 is going to start when level 1 criteria is satisfied. When level 1 is completed, then only you can go to the level 2. Here level 2 is being, in level 2, level 1 criteria are satisfied. Then the next one is access to resource. Now in here, when a particular software is being designed, multiple people are working on the particular project. So in here, each and every person has got access to all the resources. That is, there is no one person sitting at the end and waiting for the computer to be free. Everyone has got access to their set of own resources on which they are going to work on. And in here, when they are working on their resources, they're doing some tasks. Now these work tasks and the products that are being produced, they are going to be monitored. That is what you're doing. This work is going to be governed by a software engineer, or it can be a manager. Anyone can manage your, can monitor what work you're doing, and then they are controlled. Now in here, control in here can refer to, if suppose you're falling, if you're not meeting the deadline, then how you're going to meet the deadline. Then they are reviewed. After you have done everything, the manager is again going to check. He's going to monitor that everything is done. Then when you have done it, he's going to review what you have done. Then the last part is evaluation. Now this evaluation is done for adherence to the process description. That is, in here, whatever process was described by the end user, whether or not the same thing you're producing or not, that will be checked in within the managed phase. So these are the 3 levels. Now moving to the next level. Now The next level is level 3. Level 3 is your defined level. Now in level 3, all level 2 criteria is achieved. When all this level 2 criteria is achieved, then only level 3 is going to start. Now in here, this process is tailored according to organization tailoring guidelines. This means that when an end user is going to tell you all the requirement of the process, he's got some different order. Like you've got 1, 2, 3, and 4. He's going to list the requirements. Now these set of requirements are going to be again arranged again according to the organization set of standards. Now it can be 3, 1, and 2. Now how the organization is going to work, how they are going to split these requirements into different teams, how they are going to operate, that is going to be performed within the defined phase. That is, end user is going to give a specific guidelines or a set of features, that is 1, 2, and 3, whereas the organization is going to rearrange them so that they can work efficiently, or how they need to be assembled within the software. Then the next phase is quantitatively managed. Now this is going to be the level 4. Now in here, when level 3 is completed, then and only level 4 is going to start within this. Then in here, quantitatively managed, the metrics and indicators are available to measure the process and quality. Now what are metrics? Metrics are some specific standards in which you're going to measure the quality of the software that you're working on. So based upon these metrics or these indicators, you're going to identify at what level of quality is being achieved by your software. There are different levels for quality, which is the best quality, the average quality, or below average. That is going to be identified within the level 4. Whereas the next level is optimized. This is your level 5. So in here, within your level 5, all level 4 criteria is achieved. When level 4 criteria is achieved, then only you move on to the level 5, that is optimization level. Now within this optimization level, that is when your entire software is being complete, you're going to add some additional information, or some additional updates will be added to the software so that you can optimize the entire software. Now this optimization, these updates can be taken by taking feedbacks from the customer, from the user. Now whenever you're using different apps, it asks you to review the software. What are the drawbacks of everything, you can list in there. Based on that, they are going to update their software for better user experience. So these are the 5 levels starting from 0 to 5. That is in total 6 levels for CMMI for continuous representation. Then going on to the next representation, that is staged representation. Within the staged representation, all the levels will be called as your maturity levels. Now in here, this model, it was designed to improve the entire process for the quality software. That is, in here, when you have to whenever there is an organization, each and every project should not have their own standard. That is, the entire organization should have a specific quality of software. That is, they need to achieve one specific goal. That is your stage representation. And it is also going to help you that whenever you're improving a particular software, if suppose you've got no idea how you're going to improve this software, so you can take suggestions or take ideas like from similar work that was done, how they updated their software. You can take an idea and then add some more innovative steps into it, and then you can improve the entire model. Now this is a representation of the maturity levels. In here, you can see you've got 5 levels starting from level 1. Level 1 is your initial, level 2 is managed, level 3 is defined, Level 4 is quantitatively managed and optimized. These are similar, nearly similar. In continuous and staged model, you've got similar models. Now in level 1, now if suppose a particular organization or a particular company is at level 1, it means that when a specific input is given, they are generating some specific output. That is, all companies are going to have a department that is for a specific input, you're going to generate a specific output. And this will be called as a reactive level. In here, process can be unpredictable or poorly controlled. That is, for some specific give, whatever they're given, you're just generating a specific output at level 1. Whereas when it is coming to level 2, when an organization is at level 2, for one specific input, you're going to generate a specific output. And in here, you're also going to work upon the profit margins. What is the profit that you're going to gain for a particular project? Now in here, when a particular company is at level 2 at a managed level, in here, suppose there are two projects. There is a project A and there is a project A and there is a project B. Now in here, within this project A and B, every project should have a particular standard. Now in here, if suppose this particular project A, it is meeting a standard X, and project B is meeting a standard Y. Two different standards are met. Now this X and Y, these are excellent standards, but each and every project has got different level of standard. At project level, standards are given. Whereas at level 3 criteria, or when a company is at level 3, what happens in here? It is at defined phase. Now at defined phase, now within this example, as you've taken, project A and B are following standard X and Y. In here, the entire company or the entire organization is going to follow one specific standard. One standard they are going to follow. All projects that are going to fall into this category, or all the projects that are governed by this company or they are working on, they are going to have one set of standard only. And in here, this is called as your proactive level. They are going to use the best tools based upon the organization standard. All that are defined at organization level, they will be followed. The next level is the quantitatively managed. Now within this quantitatively managed phase, when a particular company is at quantitatively managed phase, you're basically going to talk about numbers. You're just going to talk about all the numbers, like what is the statistics, what are the data that you're using, what is the revenue that will be generated by the successful implementation of this project. You're going to talk about numbers. That is your quantitatively managed project. Whereas the next phase is your optimizing phase. Now within this optimization phase, when this company is at optimization phase, it means that all the numbers that you were talking about in the level 4, in here you're going to add some innovative ideas to it. You're going to add innovative ideas to it. Now an example is that if suppose a person like comes and talk, like last year the revenue of the particular company was so and so, or so much percentage, how you're going to increase the revenue for this year. So you're going to add some innovative ideas, some techniques, some updates will be added. That is called as your optimization phase. You're going to make improvements within the software. Every time you see whatever apps that you're using, each and every app gets a timely updates you're going to get that improves the features that were already defined within the software, or some new features are also added within the software. Now based on these new features, the revenue of the entire software is going to increase. The stakeholders are going to earn more from this particular optimization. And even you can see that both two persons are going to get benefited, the stakeholders as well as the end users. These both are benefited within this process, within the optimization process. So this is the CMMI staged model. Now, why we're using CMMI model? what is the use of like why companies are making use of CMMI model. Now the CMMI model, it acts as a seal of approval within the entire software industry. This acts as seal of approval in the software industry. Now it also is going to help you in various ways of how you're going to improve the software quality. It is also going to add many improvements to the entire process that you're following. So this, we are using the CMM model because it acts as seal of approval for the many software industries, and it is also going to improve the quality of the software, and it is also going to improve the process that you're following, the steps that you're following to implement the software. And it might also help as a communication between the project and the team, how they are communicating, how they are going to improve the standards, how they are documenting. That all is going to be checked in here. That is why many companies follow CMMI model. Now this is the end of the CMM model. The next topic is process patterns. Now what are process patterns? Now in here we know that what is a process. A process is the different steps that you're following to develop a software. That is what are the different actions that you're following, what are the different tasks. Now based upon that tasks, what are the products that are going to be delivered. We've got this task, what task you're doing. Based upon this task, what work products are produced that are going to develop one software. Now in here, within this process patterns, you have got multiple patterns. Now let's take an example of a process pattern. Now suppose we'll take first a normal example. This suppose you're looking for renovating your home or renovating your room. So in here, when you approach these renovating companies, interior designers, they're going to handle you many catalogs. Now when they handle you these catalogs, they're going to have many implementations. You've got multiple implementations of this, of wardrobes, of the seating arrangement, of the bedding, each and everything. You've got multiple implementations. Now based upon what you want, you're going to select that particular pattern and you're going to implement it within your home or within your room. Based upon this, whenever you're working on a software also, for a particular software, you're going to have different patterns because softwares are developed everywhere. The world is dependent upon the software. Softwares are implemented at for every task. You've got a software. So in here, you've got many similar applications also. For the similar applications, you've got different patterns. Or if suppose you do not have a similar application also, whenever you're making a software, you're going to make a pattern to it. Like whenever you're working on a project, you make the documentation. Within the documentation, you write why you're using this particular software for this particular project, what is the uses, and you write the conclusion. The same way you're going to make use of process patterns. Now we'll take an example of an Ambler process pattern. Now within this pattern, the first thing that you need to write is a pattern name. That is, within this 8, you've got 8 different things that you need to define for a process pattern. In here, you've got the pattern name. Within pattern name, you need to give a meaningful name that is going to give you the functionality of a particular software process. Now, for example, if suppose I'm writing customer, for customer, I also need to write the function that is going to be communication. For a particular customer, this is a communication. That is, you're giving a meaningful name. You're giving meaningful name that is going to tell you what is the function of this particular pattern. Then coming on to the next one, that is intent. Intent is going to tell you why basically you're going to use this particular software. What is the scope of the particular pattern? What were the basic requirements for this particular pattern? and what were the constraints. Constraints in here means that limitation. Now if suppose whenever you're designing a particular software, the end user might also come up with limitations. Now these limitations can be some particular cost, that you need to finish the entire software within some specific cost only, within these many thousand rupees. And the next one can be constraint and technology. They want this particular technology only to be built within the software. That is, if suppose you are designing a particular phone, a low budget phone, so you want some specific technology to be embedded within that, some specific operating systems only need to be there. That is the constraints. And within this constraint there can be also some limitations of time. That is, the software need to be completed within some specific time. Whereas coming on to the type, within this type, there are three different types. You've got task pattern, stage pattern, and phase pattern. Now, task is detailed steps of whatever task that you're performing within the process. You're giving in detail, you need in detail, step by step, what you're doing. That is task pattern. Whereas in stage pattern, these tasks are going to be, many tasks will be combined and they are going to form one stage. That is, if suppose I complete 5 tasks, 5 tasks is going to form one phase. Whereas a phase is interaction of 2 or more phase patterns. Now in here, there's an example, that is one model that we are going to study. That is, will be your spiral model. There are different phases, and how these different phases are going to interact, that is going to be told within the phase pattern. Then the next one is your initial context. Now this initial context is going to tell you the condition in which this pattern applies. You're going to have the particular condition. When you have this particular condition, then only this particular pattern is applicable. Whereas the next one is problem. Now what problem in here means, what is, why you're developing this particular software. Then the next one is solution. Now in here, solution means your implementation. For this particular pattern, now suppose a problem is that you are unable to go to the restaurant and fetch your food. So that is your problem. So the solution will be, you need to develop an online service that is going to get your food from the restaurant to your home. So this is the problem, and based upon that, you've got the solution. Then the next one is the resulting context. Now within this resulting context, it means that when you're using this particular pattern, what is the successful implementation, whether this particular thing was a success, you're going to identify that what was the exit phase. Whenever you're developing a particular software, you can get success or you might also fail. So you're going to identify, you're also going to write within this that whether this was a success or whether it was a fail. Then the last one is related patterns. Now in here, for this particular problem, that is, for this particular problem, if suppose there are more options available, like if suppose you've got one particular person, they have followed the Swiggy app, one might have followed the Zomato representation, then there are the Uber Eats. So there are different related patterns that will be mentioned in here. So this is a representation of whenever a software is being prepared, you're going to write the entire pattern for that. That is basic representation. That is when you just see the heading of these few things, you're going to identify and pick up which best meets your particular software requirement. Then The next topic is process assessment. Now, by the term assessment in here, assessment does not guarantee that the software is going to be delivered within a specific time, or all the requirements will be met, or there is not going to be any error within the software. Now, error in here, I mean that the end user has told one type of feature to be added, but the developer has understood it a different way, and he has implemented a different thing. So assessment does not guarantee these all things, but it guarantees an attempt to keep a check on the current state of the software process within the intention of improving it. That is, if suppose in here you're within the planning phase. Now within this planning phase, what you do? You identify the risks, you make a schedule, you even identify the scope of the project. Each of the different things that you plan in here. So in here, you're going within the planning phase, there are different things. Now in here, when you identify the risks, you can try to eliminate this risk, you can try to remove all of this risk. So in here, you're going to check on this particular state so that you can improve it. Now if suppose you are within the design phase, you're designing an architecture. Now an architecture is basically a blueprint of the software with all the circuit representations, everything. You're going to draw a blueprint. Now in here, while designing, you're going to identify and try to eliminate these risks within the software. That is process assessment. You're trying to improve it. Now within this process assessment, there's a diagram. Now whenever you've got this software process. Now whenever a software process is implemented, it is going to be examined by the software process assessment for improving the software. Now whenever you're doing this, it is going to lead to two things. That is a capability determination. That's the previous model, which level your company falls in, or which level the particular software is achieving. What are the different capability levels? The 6 levels that were incomplete, performed, managed, defined, quantitatively managed, or optimized. Which phase it is going to identify. Now while you're determining the capability, it is going to motivate software process improvement. That is the optimization phase. It is directly going to lead to process improvement also, but this is also going to motivate the process improvement. Then within this, you can see there is a direct link that is connecting the capability determination to the software process, and the software process improvement to the software process. Now this is used so that you can identify the capabilities and risk. You can identify the capabilities and the risks, and the later side, it is going to be used for identification and modification. Now the name in here, improvement, means whenever there is a modification to the software, then and only you can improve the software. If you make any changes, you're going to add some innovative ideas, then and only it is going to act as a process improvement. Whereas within the capability determination, you're going to identify any risks that are there within the software, or which level of capability it is achieving. You wanted to achieve some different level of process capability that you're going to identify within the particular software. There are also a few standards that are defined for the process assessment. The first one is the SCAMPI, that is the standard CMMI assessment, that is SCAMPI. Now this particular technique, it is going to provide you with a 5 steps assessment. 5-step assessment is going to be used. Those 5-step assessment model that is going to include initiation, diagnosing, establishment, acting, and learning. Now initiating is how you're going to start your particular project. Then diagnosing is you're going to analyze or examine any types of errors, how you're going to modify the maturity. Establishment is how you're going to design the entire software. Then you're acting on it, that you're doing the coding part, the testing part. Then learning part is you are going to learn from the mistakes that you have made and how each and every process is going to react on the basic set of requirements. Then the next one is CBA IPI, that is the CMM based appraisal for internal process improvement. Now this is used as your diagnosing technique. The one that we were using in Scampi, that is used in CBA IPI. This one is the prime focus in here. In here, you're going to make use of the CMMI model. Within the first one, you have 5 different steps. Within the second one, you're just focusing on diagnosing. Now in here, diagnosing is identifying the maturity of the software. Then the next one is SPICE, ISO IEC 15504, that is the software process improvement and capability determination. Now this SPICE, this is a standard that is going to define a set of requirements for a software process. That is all the requirements that are there that are going to be defined in here. And in here, this is the intent of the SPICE is to assist the entire organization in developing and evaluating any defined software process. That is in here, how many software processes are being developed and how you're going to evaluate all of these software processes. That is the help of using SPICE. Then the next one is ISO 901 to 200 for the software. Now this is an internationally acceptable software that is used worldwide or international scale. This applies to any organization, that is all organizations will be able to use this because this is internationally accepted. Now, when a particular software has got this type of assessment done, then in here, you do not need to again assess it. That is, this is one of the best standards that are used for the software. The entire quality of the software, the entire product of the software is going to be assessed by the international standard organization. The quality of the product, all the services are going to be internationally certified by ISO. That's the end of the class for today. Thank you.